Hello students, good morning. Welcome to today's math class. So let us continue our frequency distribution tables and graphs. So that is our 7th chapter in our textbook, and we have 3 exercises. So almost all first exercise over, one problem left, and I will complete that problem and then we will go to the next exercise. Students, in this 7.1 exercise, you look at the textbook, one problem is left over, which is a 17th one. 17th problem is left over. All of you open your textbooks and read that question. 17th question, you read it and just try to understand. Try to understand. So the given data is like this. See here. 17th question, given data is 5, 28, 15, 10, 15, 8, 24. 5, 28, 15, 10, 15, 8, 24. 5, 28, 15, 10, 15, 8, 24. This is the data. So, this is the data. I am finding its mean and mode. See here. Find the mean for this data. Mean of this data. Find the mean and mode for this data. What is the mean? Sum of all the observations by number of observations. Mean is equal to 5 plus 28 plus 15 plus 10 plus 15 plus 8 plus 24 by how many numbers? 1, 2, 3, 4, 5, 6, 7 numbers. Sum of the observations by number of observations. 5 plus 28 plus 15 plus 10 plus 15 plus 8 plus 24 by how many numbers? 7 numbers. Sum of the observations by number of observations. So add this 5 plus 28, 33, 48, 58, 63, 73, 81, 105. Students, you check it. Is it correct? Is it 15? 5 plus here 28, 33. 33 plus 15 is 48, 58, 73, 81, 85. Okay. What is the mode? Mode, which the number which occurs more times is mode. More times. 15 is the mode. Number which occurs more times is mode. Which number is occurring more times? 15 is occurring more times. So mode is equal to 15. Mode is equal to 15. 15 occurs more times. More number of times, that is a mode. Which number is occurring more times? 15 is occurring more times than the remaining. So mode is equal to 15. This is the data. But actual question is lot of confusion, students. The question is confusing. 5, 28. See here. 5, 28, 15, 10, 15, 8, 24. 4 more numbers are added. 4 more numbers are added. Students, 4 more numbers are added. 7 numbers are here. 4 numbers are written extra. What numbers? We don't know. Whether it is greater than 15 or less than 20. What numbers? We don't know. 4 numbers are added. Suppose 4 numbers are, don't write, x1, x2, x3, x4. For example, 4 numbers are like this. If 4 numbers are like this, the mode for this is, mode of this data is given as, students see, mode is increased by 1. Mode is increased by 1 means 15 plus 1 is 16. Mode of this new data is 16. That is given in the problem. See, already 7 numbers are there. Write 4 more numbers so that mode for this new data is 16. Mode is increased by 1. If it is 15, increased by 1 means it becomes 16. Now, mode is what? What is mode? The number which occurs more times is mode. So, mode of this is 16 means 16 should occur more times in this. 16 should occur more times. Already 15 is occurring 2 times means actually mode is 15. But it is given that mode of this new data is 16. That means, so 16 should occur more than 15. 15 occurs 2 times means 16 should occur 3 times. Now students, suppose if I write like this. 16, 16, 16, x. Now tell the mode for this. What is the mode of this? 15 occurs 2 times, 16 occurs 3 times. So therefore 16 is a mode. That means to get the mode 16 in 4 numbers, 3 numbers we know. How? Mode 16 means 16 should repeat 3 times. Then only mode will be answered 16. Otherwise, if it is only repeated 1 time, then 15 is the mode. In the textbook, it is given that mode is increased by 1. That means new mode is 16. New mode 16 means out of 4 numbers, 3 numbers should be 16. 1 number we don't know. Let us find it. We have to find these 4 numbers. But in that I can directly tell 3 numbers are 16s. Why? Mode is 16. 16 should occur more times. 15 occurring 2 times means 16 should occur more than 2 times. More than 2 means 3 or maybe 4 or any. Maybe 4 also. But 3 is guarantee. So therefore 3 numbers I am assuming. 4 I will calculate. I will find out. Okay. Like this. Write down. Write down some introduction. Write up to here. Write up to here. Don't write this. Up to here I will give some notes. Write up to here. Given data is like this. I calculated the mean is 15. And mode also of course 15 because mode is which occurs more times. So 15 occurs 2 times. So mode is 15. After this you write down. 4 numbers are added to the given data. 4 numbers are added to the given data. 4 numbers are added to the given data such that mean and median remains same. Mean and median remains same. Mean and median remains same. Mode is increased by 1. Mode is increased by 1. Mean and the textbook statement only I am writing. I am giving. Same textbook statement we are writing. 4 numbers are added to the given data such that mean and median remains same. Mode is increased by 16. Mode is increased by 1. Mode is increased by 1. Hence the mode is equal to 15 plus 1. 16. Mode is equal to 15 plus 1. 16. 16. Therefore, among 4 new numbers, among 4 new numbers, among 4 new numbers, 16 repeats at least 3 times. 16 repeats at least 3 times. among 4 new numbers, 16 repeats at least 16 repeats at least 3 times. So let 4 numbers be 16, 16, 16x. Don't write this. Let 4 numbers be 16, 16, 16x. 3 numbers we know, 16s only. 4th number we don't know. Let us take it as x, that we will find. Let 4 numbers be 16, 16, 16, x. Then the data is, write all the numbers. 7 numbers already given, 4 numbers we assumed. We assume means in the 3 we know, it should be 16. So x, 1 number we don't know, let it be x. Write down, total series. So now find the mean of this. What is the mean? 5 plus 28 plus 15 plus 10 plus 15 plus 8 plus 24 plus 16 plus 16 plus 16 plus x by how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. This is the mean for this. Mean is same as original mean. After adding these 4 numbers also, mean is same. That is given in the problem. Original mean of these 7 numbers is 15 and mean of these 11 numbers also 15. Mean of 7 numbers is 15, mean of 11 numbers also 15. It is given. Mean remains same. Original mean is 15, new mean also 15. Mean and median remain same, but median we are not using. But mode is increased by 1. Original mean mode 15, new mean is 16. That already we taken into account. So mode mean is sum of the observations by number of observations, but answer is given as 15. Answer is given as 15. Why? Same mode, same mean is repeated. First mean and second time mean is same. Now do it. 5 plus 8, 33. Same 33, 48, 58, 73, 81, 105. 105 plus 16, 48. 153. Total is 153 plus x is equal to 15 into 11. X is equal to 15 into 11 is 165 minus 153 is 12. Therefore, the 4 new numbers are, see students, 4 numbers are, 1 is 16, 1 is 16, 1 is 16, next is 12. Like this, lot of reasoning. So, 4 numbers we have to find. In the 3 numbers should be 16, because if these are 16 only, if this is repeated 3 times, then only mode will become 16. Mode is increased by 1. Original mode is 15 means new mode is 16. Therefore 16 should repeat 3 times. Last number we don't know. So sum of the observations by number of observations is equal to 15. From that the answer is 16, 16, 16 and 12. Over. Write down students. Write it and understand. With this exercise is over. Students, after completing this, you write the heading frequency distribution tables. Frequency distribution table, we are going to the next exercise. That means for that we have to study some extra concepts. So for that I am giving some notes. Student, suppose you got the, I will give one example. Suppose say marks of say 20 students in a class out of 100 are given like this: 35, 45, 55, 42, 69, 70, 82, 3, 6, 8, 39, 41, 40, 50, 51, 62, 73, 38, 40, 42, 43. Like this, some 20 students' marks are like this. We went to the class and we collected 20 students' marks. So if you look at these marks, of course we are getting some idea. But if it is interpreted in another systematic order, then it will be easy to interpret the given data. Suppose if I ask how many students got more than 80, that means you will count. More than 80 means okay, 1. Like this you have to count. How many got less than 40? Then you have to count 1, 2, 3, like that. So it is every time it is inconvenience. So if you arrange this in the form of a systematic table, then we can easily answer any question. So that table is called frequency table. So how to construct the frequency table? We assume some class intervals as per our convenience. Suppose, see here, don't write, it is only example. 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, only up to 89 only. So like this we take. See here. Then 35, where 35 will come? Here. We write 1. It will lie here. 45 will lie here. 55 will lie here. 42 will lie here. 69 will lie here. 70 will lie here. 82 will lie here. 39 is here. 41 is here. 40 is here. 50 is here. 51 is here only. 62 is here. 73 is here. 38 is here. 40 is here only. After 4, fifth one we write like this, so that easy to count. So this total is 50. 5. So fifth one we write like this. Next 42 is here only. We start separately. 43 is here only, like this. So total how many? This is 3. This is 5 plus 2, 7. This is 3. This is 2. This is 2. This is 1. So if you arrange like this, there are a lot of benefits. Suppose if I ask you how many students got in the range of 30 to 40, so 30 to 39, so you can tell 3 students. Suppose above 70 means this will come, total 2 plus 1, 3. Like that easily you can tell answers. So that means if this, instead of this data, this is more convenient. So this data is arranged in this form. This form is called frequency distribution table. So this is called class interval. Don't write class interval. These are called tally marks. Tally marks. These are called frequencies. Frequency means how many are there in that range. Frequency. Class interval, tally marks, frequency. See here. Class interval. Second is tally marks. Don't write anything. So I am going to explain about all this. Then third is frequency. Fourth is the starting value is called lower limit of this class. This is a class. This is one class interval. This is called lower limit. This is called upper limits. So class limits. Next point is class boundaries. So these points, now I want to give some notes. So this is a class interval. Anyway you can take. Suppose in the question, if it is given, take the range 10, 10, then we take like this. Otherwise, we can take as per our convenience. If it is mentioned, we take like that. Otherwise, we can take any interval. 30 to 35, 30 to 34, 35 to 39, like that also you can take. Any order. So tally marks you know, frequency you know. So this is starting is called lower limit of the class. This is called upper limit of the class. Lower limit, upper limit. Next also, size of the class also I will explain. Size of the class or class interval. Size of the class. Length of the class. Like this. So these points I am explaining, students. This table is called frequency distribution table. Write down the heading. Write down the heading. Frequency distribution table. We arrange the given data. We arrange the given data in the form of a table. In the form of a table. In the form of a table. In which we take suitable class intervals. Suitable class intervals. For each class interval, you write next sentence. Next sentence. For each observation, or each observation you write down. Each observation is denoted by a tally mark. Denoted by, each observation is denoted by tally mark. Tally. Each observation is denoted by tally mark. Each observation is denoted by tally mark. Next line. Next line. Number of observations. Number of observations in a class. Number of observations in a class is called its frequency. Is called its frequency. Denoted by F. Number of observations in each class is called its frequency, denoted by F. Denoted by F. Next line. Next line. In a class, okay, write down one example. In a class 30 to 39, in a class 30 to 39, starting value 30, starting value 30 is called lower limit. Starting value 30 is called lower limit. Starting value 30 is called lower limit. Ending value 39 is called upper limit. Ending value 39 is called upper limit. Ending value 39 is called upper limit. Students, limits and boundaries, there is some confusion. I will explain. For this class, what is the lower limit? 50. Upper limit is 59. Now boundary means what? See here students, I want the boundaries for this class. Limits, it is very easy. This is the lower limit, this is the upper limit, no issue. But boundaries, how to find? Boundaries, so this 59, upper limit of a class, lower limit of a next class by 2. This is 59.5. 59 plus 60 is 119 by 2 is 59.5. So this is called upper boundary of the class. Boundary. Upper boundary is not 59. Upper limit is 59. Upper boundary is upper limit of a class plus lower limit of the next class by 2. That is 59.5. So this upper boundary will become lower boundary for this class. What is the lower boundary for this class? Upper boundary 59.5 is the lower boundary for this. That means 59 plus 60 by 2 is upper boundary of this, also lower boundary for the next class. That is the difference between boundaries and limits. Limits. Suppose if this is 50 to 60, 60 to 70, in that case limits and boundaries will be same. If there is one difference, then only limits will be different, boundaries will be different. So boundary of upper boundary of this class is 59.5. Write on the next line. Boundaries. Class boundaries. Next point. The average of upper limit of a class, the average of upper limit of a class and lower limit of the next class, the average of upper limit of a class and lower limit of the next class, the average of upper limit of a class and lower limit of the next class is called its upper boundary, is called its upper boundary. Upper boundary. Upper boundary of a class, write down. Upper boundary of a class, upper boundary of a class becomes, upper boundary of a class becomes lower boundary for the next class. Upper boundary of a class becomes lower boundary for the next class. Upper boundary of a class becomes lower boundary for the next class. Upper boundary of a class becomes lower boundary for the next class. class boundaries are also called, there is another name for the boundaries. They are also called true class limits. But we generally use boundaries only, but it is also called true class limits. Write down. The boundaries of a class are also called true class limits. True class limits. True class limits. Example I am not giving, you understand. The upper boundary is 59 plus 60 by 2, 59.5. So anyway, while solving the problems, anyway I will explain, but just understand the concept. I gave the definition of class interval. So the given data is represented in the form of a table. So that table is called frequency. That is, we for preparing the table, we take the table class intervals like this, and tally marks. Number of observations in each observation is going to be one tally mark, and number of tally marks is nothing but frequency. So this is the lower limit, this is the upper limit. Class limits also I explained. Boundaries is 59.5, 49.5, 49.5, 59.5. Boundaries I explained. Now the last point. Write down. Size of the class. What is the size of the class? See, size of the class is difference between the boundaries. What is the upper boundary? 59.5, 49.5, difference is 10. That difference is called a size of the class. Otherwise you can take like this also. 40 minus 30 is 10, or 49 minus 39 is 10. Like this you take, don't take like this. So 49 minus 40 is 9. 9 is not the size of the class, 10 is the size of the class. We should not take the difference between the limits. Difference between the boundaries you have to take. 59.5, 49.5. That difference is called size of the class. Otherwise you can take like this. 40 minus 30. Like that. Write down. Size of the class. The difference between upper and lower boundaries of a class. The difference between upper and lower boundaries of a class is called size of the class. Difference between upper and lower boundaries of a class is called size of the class. Difference between upper and lower boundaries of a class is called size of the class. Difference between upper and lower boundaries of a class is called size of the class. Size of the class. It is also the difference between lower limits or upper limits or upper boundary, lower boundaries or upper boundaries of two successive classes. The two classes, side by side classes of two successive classes. The size of the class is also, actual definition is difference between the boundaries. It is also difference between lower limits or difference between upper limits, difference between the lower boundaries, difference between the upper boundaries, all will be same. Anything gives the size of the class. Two successive classes, if you see the difference between the limits, that gives the size of the classes. Difference between lower limit or difference between upper limits, or difference between lower boundaries or difference between upper boundaries, or difference between upper and lower boundaries is called size of the class. Write down this. So size of the class also explain. Next, last point. Write down frequency distribution table. Write down this last point. Frequency distribution table. Frequency distribution table. Right now, the class, the table which consists class intervals, tally mark, or just only frequency. The class which consists class intervals and frequency in each class, or frequency of each class. The table which consists class intervals and frequency is called frequency distribution table. The table which consists class intervals and frequency of each class is called frequency distribution table. Is called frequency distribution table. This is some introduction for the next exercise. So class intervals, tally marks, frequency, class limits, class boundaries, and size of the class, and frequency distribution. Some definitions I have given. So we will continue tomorrow, students.